We'll continue using residual for line of best fit with another example. So example number 2. So pause the video and copy this table down of data that were given with age, so age of a person, and their actual salary in thousands of dollars. So this person who is 41 made $47,000, and this person 55 made a salary of $45,000. So we want to know is would the model equation y equals 0.2 x plus 38 be a good model? So remember, we want to find the y values of this equation and use them to help us find each of these residuals. All right, so we'll make our table. And over here will be our residual. I'm going to do those in red. Residuals. All right, so when we calculate that, we get 45, 45.4, 46.2, 46.6, 47, 47.4, 48.6, and 49. So I would use a calculator to help calculate those out. And to find those residuals, remember we have to subtract those y values from our model equation away from our salaries y values. So those will find those y values of, and let me change colors here. So our residual would be -3, -1.4, 0.8 positive, positive 3.4, 5 positive, positive 3.6, positive 0.4, and -4. So at the first glance, I'm not really sure. So what I want to do is graph those on a graph. So grab a piece of graph paper, and we're going to graph them on a graph. So I'm going to go up by tens, I guess, on the x values because our age goes up pretty quickly. So 10, 20, 30, 40, 50, 60, and I guess that's as high as I need to go for my label. So that is my my age, and over here will be my salary in thousands of dollars. So I guess when I'm looking at my data, my biggest one is a -4. My biggest distance away is -4. So down here, I'm going to make a -4, which will make this a -2. And this would have to be the same scale up there, going up by 2. So now I'm going to plot my x values. So 35, and my residual is -3. So that would be this point right here. So we're going to put a point there. 37 would be a -1.4. So 1 would be halfway, and then halfway again, so like 3/4, but right about there. Then 41 would be 0.8, so halfway is 1, so just a little bit lower than that. 43, just below 45, would be 3.4, so 3 would be halfway, and then 0.4 is a little bit less than halfway of to 4 there. So there's that residual. Then, oh, I didn't even notice this one. 45 is 5, so that would make it about halfway distance up. And then the next one is 47 is 3.6, so just a little bit higher than that other one. 53 is 0.4, so halfway would be 1, so a quarter would be a half, so it's just a hair smaller than that, lower than that. And then 55 is -4. All right, so in looking at this, notice how it makes a kind of almost a U shape coming up and around. So that suggests to us that this is not a good model. So it's not a good model for this data set. And because it has a different shape to it, it tells us that this data set is not even linear. So there would be a different model that would fit it, maybe linear or maybe exponential or quadratic or square root function, something else that we'll be learning about later. And but the main thing is that this is not a good model because it's not evenly split above and below and near that, and it makes a different shape, a different shape.